Good morning, all of you. The sound clarity was not in the last lecture on the experimental estimation, so I am repeating this. In the experimental estimations of the EA means activation energy. What is the actual activation energy? In case of activation energy, this activation energy is utilized for the completion of the reactions. Every reactant molecules having its own energy, and every reactant use that own energy for the collision with the another reactant molecule or reagent and convert it into the product. Before converting into product, it acquired transition state, intermediate, then finally into the product. So for the conversion means achieving the transition state, achieving the intermediate, and then the final product, each reactant required some amount of energy. If molecule is having his own energy, it's sufficient to react. If molecule is not having that so much amount of energy, so that it can achieve that transition state, intermediate, and then finally products, then it is provided by the externally, and it is provided by externally to collides the reactant molecules to achieve the transition state. This externally provided energy is in the form of activation, means it activating the reactant molecules, so it is the activation energy. So this is activation energy provided to the molecules when it is required, means if reactant molecules not having sufficient at that times, externally activation energy is provided. If it is having, it is in the form of potential energy, it's having its. So there are two methods for the estimation of EA, means value of the EF to find out, means how amount of activation energy is gained or required or converted for the reactions is calculated by the EA, and EA calculated by having the two methods of the find out the calculations. One method is the chemical reaction is carried out at a different temperatures, and the temperature providing is also providing the some amount of energy to the reactants. Temperature means it is a form of energy. If you are providing temperature to the reactions, it is also one of the energy, and this energy is gained by the reactant molecules. It increases its own energy and then converted into the transition state, and then the losing this energy converted into the products. Hence the chemical reaction is carried out at different temperature, and corresponding the rate constants are determined. A graph of the log k versus 1 by t is plotted. Log k means the reaction constant, rate constants versus temperatures is plotted. EA activation energy is calculated from the slope of the straight line. Graph plotting, after plotting the graph having the some values, find out these values, we can find out the EA activation energy. EA is equal to minus slope in bracket 2.303 R having the some constant values. Another second method is the chemical reaction is carried out at a temperature T1 and T2. It is two temperatures. By using the values of two different temperatures, means at a T1 the value of rate constant is K1, then log A is equal to EA divided by 2.303 RT1, temperature 1. If having that another temperature T2, means log K2 is equal to log A, value is the EA divided by 2.303 RT2. So if having the two temperatures, at that time we can combine these two temperature and find out the final equation for EA. So, comparing this, taking the difference between them, that is log K2 minus log K1 is equal to EA, taking the similar parts aside and the common parts in the brackets, different part asides, common part in the bracket, that is the different part in the bracket and common part asides, means that multiply and we will get the final equation. The common part is the EA 2.303 R in bracket 1 by T1 minus 1 by T2. Then the final log K2 divided by K1 is equal to EA 2.303 T2 minus, if you are taking the LCM of this equations, we will get the T2 minus T1 divided by T1 T2. EA is equal to 2.303. Finalize these equations. 2.303 R T1 T2 log K2 divided by K1 divided by T2 minus T1. This is the final equation. So, by using this equation you can easily find out the value of EA. Next part is the problem parts. There are very simple numerical problems on this part. They are given the two different temperatures T1 T2, and by using this temperature you have to easily find out the rate of the reactions. So, you can easily find out here the here the reaction, if the rate of the reactions doubles from the 22 degrees centigrade to 32 degrees centigrade, calculate the energy of activation. In this problems we have to find out the value of EA. We know the formula. We have the formula, that is log K2 divided by K1 EA divided by 2.303 R T2 minus T1 divided by T1 T2. So, by using this formula, rearranging the formula, we can easily find out the value of EA. So, we have first of all, we firstly write down the what problem we have, values write down in the givens, that is T1 is equal to 22 degrees centigrade. So, what is conversion of degree centigrade into the Kelvin is the 22 plus 273, we will get the 295 kelvins. Second temperature is 32 degrees centigrade, conversion of this degree centigrade into the Kelvin is the 32 plus 273 means 305 kelvins. Next is the K2 is equal to 2 K1, means K2 divided by K1 is equal, we know that the rate of the reaction doubles from 22 to 32 degrees centigrades, means the K2 value is double of the K1 values. The K2 is equal to 2 K1. If we taking aside K2 divided by K1 is equal to, we will get the 2 value. So, this using this equation, this is most important key of this numerical problems, because we have the value of T2 T1 and we have the value of K2 constant values, not in the, it is in the form of proportions. So, by using this value we can find out the EA, because in the EA there is only 4 terms, that is K1, K2, T1, T2. We have to find out. R is the constant terms. So, we have the equations, we have the comparatively value of K2 divided by K1, ratio values, it is equal to 2. We are putting this value 2, we know the T1 T2, then we can easily find out the value of EA. So, putting the value of K2 K1 in this reactions, log K2 divided by K1 is equal to 2, then the EA divided by 2.303, R's value is 8.314 universal constants, value of T1 T2 is the 305, T1 is the 295 divided by 295 into 305. Solving this, we will get the 10 divided by 899.75 is the final 89975. EA divided by, simplifying the 2.303 multiply 8.314, we will get the 19.1471 is the value. Then the log 2's value is the 0.3010 is the log 2 values. Now, finalizing these values, we will get the EA is equal to 0.3010 into 19.1471 divided by 1.114 into 10 to the power minus 4. Simplifying this value, again we will get the 5.7632 divided by 11 into 10 to the power minus 4. Simplifying this value, we will get the 5.1855 into 10 to the power 4 is the value of EA, means the energy of activation. This is the simple way to find out, and this is simple numerical problems. Second numerical problem is same as the above. The racemizations of alpha pinene is the first order reactions. In the gaseous phase, the rate constant were found to be the 3.667 into 10 to the power minus 7 per second. Here is the gas constant value is given at 457.6 Kelvin and 5.11 into 10 to the power minus 5 at per second at 510.1 Kelvin. Calculate, means here is the no ratio is given, is directly values of the K1 K2 given along with the value of T1 T2 given. Means T1 value is the 457, K2 K1 is the 3.667, T2 is the 510, K2 is the 5.1. Putting these values in the above equations and simplifying this, means the log, putting the value of given into the formula, we have the formula that is log K2 divided by K1 is equal to EA divided by 2.303 into R. This is our main formula. We have used this formula in the two reactions, two numerical problems. So by using this formula, we can easily find out the answer. In this formula, the terms are the K1, K2, T1, T2. We have to find out E1. R is the constants, means the whatever by leaving the EA, remaining all the terms we know. Putting the value of that unknown known terms in that equations, we will easily find out the value of EA. So start to put the values. Value of K2 is the 5.117 10 to the power minus 5. Value of K1 is the 3.667 10 to the power minus 7. EA divided by 2.303. Value of R is a universal constant, that is 8.314. T2 minus T1, T2 value of T2 is the 510.1 minus value of T1 is the 557.6 divided by value of T1 is the 457.6 into 10 and the value of T2 is the 510. Simplifying this equation, we will get the answer. Simplifying this equation, we will get the answer. Easily answer. This step is, next step is the written here, but no need to rewrite here. You can do simplify it aside in another page also. This part, don't write this part in your answer. It is calculating part. You have to do this part on the sides. So putting the finalizing the value, we will get the EA is equal to 18.26 into 10 to the power minus 4. So this is the simple way to find out the answer. EA is the 182.5 into the power 3 is the value of EA. So in this way you can find out the various problems, various questions are asked on these values and two values are given, that is the value of T1, T2 and the value of K2 and K1 is given. By using these values, we have to put this value in the well-known formula and find out the step by step solve the questions and we will get the finally correct answer. So this is all about the numerical problems asked on these topics. So next, in the next part we will study the theories of reaction rates. We will discuss it in the next lecture. Thank you very much.